In this lesson, we are going to be looking at matrices as a way to both solve some problems, do some operations with them, just a kind of a neat little way to organize your work when you're doing some things mathematically, okay? So what you need to know is that a matrix, it's called, is basically just a rectangular way to organize data, okay? They go in rows and columns. So these are the rows, okay, and these are the columns of a matrix. Just so you know, columns are up and down, okay? This particular matrix on the left has 2 rows and 3 columns, so it is a 2 by 3 matrix. Always, 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 the rows comes first and the columns come second, every single time, okay? The right-hand matrix is a 3 by 2 matrix because it has 3 rows and 2 columns. This particular matrix over here, as you can see, has 2 rows and it has 1, 2, 3 columns. So it is a 2 by 3 matrix. And then what you need to know is each number that's in this matrix, and matrices don't always have numbers in them. Sometimes they're letters or whatever, but in this particular case, they're all numbers. Each of these is called an element, okay? So it's an object in a matrix is simply called an element. The next question is asking you, what is the element A23? What that means is what is in the position of row 2, column 3? That's what it's asking you. What is in the position of row 2, the second row, third column? Here's the first row, here's the second row, first column, second column, third column. So second row, third column would be this element right here, and it happens to be a 6. Okay? All right, then we are going to look at some specific kinds of matrices. Square matrices have the same number of rows and columns. You can see some examples and non-examples of a square matrix. If it has a different number of rows and columns, then it's not a square matrix. Okay? Equal matrices have the exact same elements in them. So if you compare matrix F with matrix G in this particular example, it starts out good. It has a 1 and a 1, a 2 and a 2, the same exact numbers in the same exact positions. The problem is when we get here, looking at these ones that are highlighted, it does not have the same number in the same position, and so these two matrices are not equal. Okay? Then I want to take a look at adding and subtracting matrices. Okay, in order to add and subtract them, they have to have the exact same dimensions, the same number of rows and the same number of columns. Both of them do. So like if I look at this particular example up here, I can see that this is a 3 by 2 matrix. This is also a 3 by 2 matrix. They both have to have the same rows and the same columns. Okay, all you do to add and subtract is you add and subtract the numbers that are in the corresponding positions. So if I was going to add these two matrices together, I would add A1 and C1. They're both in the upper left-hand corner of that matrix, row 1, column 1. The answer would go in row 1, column 1. Okay? Row 1, column 2 plus row 1, column 2 would equal row 1, column 2. That's all you do. Same thing for subtracting. You just add and subtract the numbers in the same positions. Okay? So here's some examples that you can see that I just carried out really quickly. I'm not going to go all the way through this, but if I was doing the bottom one, to subtract these, I would take 1 minus -4. 1 minus -4 clearly is 5. Move on to the next position, subtract the numbers, record the answer in the same position. Okay. Then we're going to do an example with what's called scalar multiplication. All that means is that you multiply every element in the matrix by the same number, okay? So in this case, it's talking about a consumer advocacy group that's looked at mean retail prices for some different brand name and generic products at different stores in some cities, and it lists the price there, okay? Then what it's saying is that the city takes all of the items at their store and they add a 7.25% sales tax to it. So it would seem that you would add 7.25% to each of these, but if you remember some math from previous years, what you want to do is you want to come up with a number that you can multiply each of these by so that you get the price back again with the sales tax added onto it in one step. Okay, so here's what I want you to think about to remind you of this. If I multiply this entire matrix by 1, obviously 1 times 3.97 is 3.97. 1 times 3.64 is $3.64. Okay? If I want to do the sales tax on it, I'm going to multiply by 1 so that I get back my original price, and that doesn't go away. And then I'm going to add the 0.0725 to it, so that I get the tax on there. So when I multiply 1.0725, I'm going to do that to each element in the matrix. So I'm going to take 1.0725 times this, 1.0725 times that, 1.0, I think you get the pattern. Okay? I didn't take the time to do all that, but you can check your work if you want to check it. And this is what happens. When you multiply 1.0725 times every single number, you can see the results there. Okay? All right, then we want to look at the zero matrix. The zero matrix literally just has the number 0 in it, okay? That's it. If it might be a 2 by 2 matrix that has all zeros in it, or a 3 by 3 matrix, whatever. As long as it has all zeros in it, it's a zero matrix. Okay? Then, what you need to know is the additive inverse. So think about this just with normal numbers, not numbers in matrices. The additive inverse to 3 is -3. The additive inverse to -5 is +5. Okay, you can see they're just opposite numbers. Same thing with matrices. The additive inverse will be the same exact matrix where you switch the sign in every element of it. Okay, so if you see how this is +1, this becomes -1. 0 doesn't switch signs. +2, -2. Okay, same exact matrix. I just switched all the signs in it. All right. Now we get to do matrix multiplication, which is just a little bit tricky. We're going to do this by hand, and we're going to do it on our calculators too, so that you can check them. I will tell you that there will be one problem that you're going to have to do on a quiz or a test where I am going to make you show your work by hand, so that I make sure that you understand kind of the process, because it is important in what you're going to do later, that you know a little tiny bit about how to do this by hand. Okay, even though you can check your work on your calculator. When you do matrix multiplication, you basically take every row in the first matrix and you multiply it by every column in the second. That's what happens. You take every row in the first matrix and you multiply it by every column. So if you can see what's happening here, and I'll do an example of it, that's what shakes down. I want you to notice this. I did row 1, column 1. My answer went in row 1, column 1. Okay? If I do this, row 1 and column 2, my answer goes in row 1, column 2. Okay? That's the position that it goes in. Okay? And we'll do an example of this. It gets to be a little bit tricky, but that's kind of what this diagram is showing us, that you pay attention to what row and what column you're doing to put your answer in the corresponding spot in your answer matrix. Okay? So here we go. First of all, we're going to multiply these two matrices by hand. What I want to point out to you from the very beginning is that this is a 2 by 3 matrix because it has 2 rows and it has 3 columns. This one is a 3 by 2 matrix because it has 3 rows and it has 2 columns. What you need to know is that not every matrix can be multiplied by every other matrix. Okay? In order for you to be able to multiply them, these two inside numbers have to match. So the number of columns in the first matrix has to match the number of rows in the second matrix. If I were to switch these two matrices around, just so you know, so that this was matrix B and it was a 3 by 2 matrix, and this was matrix A and it was a 2 by 3 matrix, it would also work in this case because these are both 2's. Okay? If they weren't both 2's, it would not work. Your answer is going to be different when you switch them around, but I can do it. Okay? You can't always multiply in both orders. Like 2 times 3 is the same thing as 3 times 2 when you're dealing with single numbers. That's not true with matrices, just so you know. Okay? Anyways, those 2 inside numbers have to match, which they do in this case. I will tell you this. Your answer matrix will be the other numbers. Okay? Your answer matrix will be 2 by 2. Okay? Just so you know. So here we go. We're going to do this and kind of have this a little tiny bit animated so that you can kind of see what's happening. Okay, so the first thing you're going to do is you're going to start by multiplying the first row by the first column. Okay, so this is what I'm going to do. I'm going to take the first row and I'm going to multiply it by the first column. Okay, here's what that means. So again, this is what I'm doing. I'm taking row 1 and I'm multiplying it by column 1. So you can see how I took that first row, I spun it, and I set it next to the column that I am going to be multiplying by. Okay, so here we go. This is what I'm going to do. I'm going to make an answer matrix. My first answer is going to go in row 1, column 1. Here's what I do. I take 1 times 1 plus 2 times 2 plus 3 times 0. So I'm going to write that out. 1 times 1 plus 2 times 2 plus 3 times 0. Okay? That is going to give me a number, and it's going to give me an answer, which I will tell you, and I know you can simplify that. And when you simplify that, you get the number 5. Okay? So I've done row 1 by column 1. Now what I want you to do is I want you to think of distributing that row through the second matrix. So I'm going to move this row over. Okay, and now I'm going to do the top row and the second column. Okay, so now I'm over here and I'm going to do 1 times 0 plus 2 times 1 plus 3 times negative 1. Okay, so here we go. 1 times 0 plus 2 times 1 plus 3 times negative 1. Oops, not negative 7. Sorry, negative 1. When I simplify that, I get negative 1. Okay, now you can see that I have distributed that top row all the way through that matrix. Okay, if there was another column, I would move it over to the next column and multiply, but there's not. So I'm done with the top row. I've done it through that whole thing. I'm just going to scoot it out to the side so I can ignore it. Okay, I've exhausted my options with row number 1. Now I'm going to go to row number 2. Okay, I'm going to think of turning it on its side, moving it over here, and I'm going to multiply it by the first column. Okay, so I'm going to go 0 times 1 plus 1 times 2 plus negative 1 times 0. When I simplify all of that, I get the number 2. Okay, notice I multiplied the second row by the first column when I did that. My answer went in the second row and the first column. Okay. So I'm going to keep moving that row through that second matrix, until I'm done with all of the columns. So I move over to the next column now. Okay. And now hopefully you can see that I'm going to do 0 times 0 plus 1 times 1 plus negative 1 times negative 1. And when I distribute all of that and simplify it, I also get a 2. Okay, this is my answer. My answer is still a matrix. Okay, but that's the process. All right, some other vocabulary that you need to be familiar with. One of them is the identity matrix. Basically, that means that in the main diagonal, and the main diagonal is the one that goes from the upper left to the bottom right. This is the main diagonal. This is not the main diagonal, just so you know. Okay, so the main diagonal has to go from top left to bottom right. Those are ones. Everything else in that matrix is a 0. No matter what the dimensions of the matrix are, as long as the main diagonal is 1 and every other number in it is 0, then it is an identity matrix. Okay? Then we are going to look at trying to find some inverses of matrices. Okay? So when we're dealing with regular numbers, 2 and 1/2 are inverses of each other. 2/5 and 5/2 are inverses of each other. Okay? Um, when you multiply them together, you get the number 1. When you're doing matrices, you also have inverses, but in order to find the inverse, it's just a little bit trickier. Okay? So this is saying on a 2 by 2 matrix, we can do this by hand on a 2 by 2 matrix. I will also show you how to do it on your calculators. Oh, you know what? I should go back to that last example and show you how to do this on your calculator really quick. Okay, I'm going to do that. So here we go. On our calculators, we are going to do this and get an answer on our calculators. So I'm going to go here. So first of all, we have to enter the matrix into our calculators. You can see on your calculator screen that you have a little matrix key right here. It's blue, so I have to access it with a second key. So I will do second, and then that x-1. Oops, I have to get rid of this, sorry. Okay, this menu comes up. Whenever you're wanting to change numbers or input numbers into a matrix or change the ones that are in the matrix, then you have to use the edit option. So the edit option allows you to either input the numbers or change the numbers that are already input. Okay? So I'm going to go and I'm going to scroll over to the edit, and then I'm just going to tell my calculator I want to edit matrix A, which is number 1, and I'm going to hit edit. Notice it asks you to give the dimensions. So in the problem that we did, matrix A was a 2 by 3 matrix. So 2, I'm just entering this, 3. Okay, then you can see that the matrix comes up, and you can simply enter the numbers in there. 1, 2, 3. Just use your arrow scroll. Okay, there's matrix A. I've input matrix A now. That's all I've done is just input the data. I'm going to just go back to my main screen. So I'm going to quit out of here and do second mode. Okay, now I need to input matrix B. And again, to access the matrix menu, you're going to go second, x-1. Okay, I've got A in there the way I want it. I don't want to touch it, but I do want to put B in. In order to put B in, I have to go to the edit menu. This time I want to go down to number 2. I'm going to put B in. B, if you remember, was a 3 by 2 matrix. Oops, that didn't work so well. Let's try this again. All right, 3 by 2 matrix. Okay, and I will input that in. All right, got that in. Okay, again, all I'm doing when I'm in the edit menu is entering data. So I'm going to quit out of there. Now I'm on the main screen, the same place that I would add 5 plus 5 and get 10. Okay, same place. I'm on the main screen. I want my calculator to multiply matrix A times matrix B. So I have to pull it up from my calculator. I have to pull up matrix A. So I'm going to go second matrix. I want to select matrix A. So I just chose number 1. Then I want to multiply that by matrix B. I need to pull up matrix B by just doing the matrix menu and number 2. Okay, hit enter, and notice it spits out your answer as a matrix for you, and that does check with the ones that we were doing. Okay, all right, back to looking at some inverses. All right, so in order to do an inverse, first of all, this is what you need to know. Matrices have to be square to have an inverse, okay? If they are not square, they do not have an inverse. You just need to know that. And the other thing is to find the determinant, and the formula to find the determinant is right down here. To find the determinant, I take this diagonal and multiply it. And so A times D, and then I subtract this diagonal, B times C. That's my determinant that it's called. If your determinant is 0, then you can't find the inverse. Because to find the inverse, you need to use this handy-dandy little formula. And since you can't divide by 0, if the determinant of a matrix is 0, you can't find the inverse. Okay? So in order for a matrix to be inverse, it has to be square, and you can't have a determinant of 0. All right? So just so you know that, we are going to well, we're going to do that. Okay, we're going to do this on our calculators too. But if I gave you a 2 by 2 matrix and I asked you to find the inverse of it, I think you could follow that handy dandy little formula and do it. And we are going to do that in just a minute. Okay, and then in order to prove that two matrices are inverses of each other, you have to take A times B and get the identity matrix. And remember that the identity matrix goes something like this. 1's in the main diagonal, okay, 0's everywhere else. So I have to take A times B and get an identity matrix, and then I have to do it in reverse order, B times A, and also get the identity matrix. And I have to do it both ways. I can't just do it one way, okay? So first of all, I'm going to do this example. We're going to do it by hand, and actually we're just probably going to do this on our calculators. But I want to know, first of all, just if this has an inverse. Okay, so the two tests to see if it has an inverse are, first of all, that it's square. This is 2 rows by 2 columns. It is a square matrix since it's 2 by 2. And the next thing I have to figure out to determine if it has an inverse or not is if the determinant is 0. Okay, on a 2 by 2 matrix, I can find the determinant, again, by multiplying this diagonal, so 5 times 3 is 15, subtract this diagonal, 8 times 1 is 8, and so I get 7. My determinant, in this case, is 7. Okay, I'll show you how to find that on your calculators as well. Then I want to find the inverse, okay? So I can find the inverse with that handy-dandy little formula, which is 1 over AD minus BC, which is the determinant. And then, if you remember, the formula, and this is on your previous page if you want to look it back up again, it is D, negative B, negative C, A. And in this case, this is A, this is B, this is C, this is D. So if I were to do this, I would do 1/7 times 3 times negative 1 times negative 8 times 5. Okay, I would take 1/7 times each of those, and then when you do that, you're going to get 3/7, negative 8/7, negative 1/7, and 5/7. Okay, so that's how you do it by hand. I'm going to show you how to do determinants and inverses on the calculator, and then we're going to prove these really quick. Okay, so here we go. We are going to go back to our calculators. I'm going to input that matrix that I gave you. So again, I'm just going to clear this as the main screen right now. I'm just going to clear it so that we're not confused. I want to enter in some data. So I need to go second matrix. And then when I want to enter in data, I have to enter it in under the edit menu. Okay. In this case, our matrix is not a 2 by 3, but it's a 2 by 2. And it went 5, 1, 8, 3. Okay, so I gave you how to find determinants of a 2 by 2 matrix. You can find determinants of other matrices as well. They have to be square in order to find a determinant, but you can find them of any dimension, and I'm going to show you how to do that on your calculators quick. Okay, so here's what you're going to do. I'm on the main screen. Okay, to find the determinant, I want to go second matrix. If you go over to math, it gives you some options. Okay, One of them is determinant, which is number 1. So I'm telling my calculator I want to find the determinant of matrix A. So pull up matrix A for your calculator. And we already know that the determinant is 7. Okay, then if I want to find the inverse, when you see this symbol like that, this -1 that's up here is the symbol for inverse. Okay, just like 2 to the -1 is 1/2, okay, with a negative exponent, that -1 symbol means you're finding the reciprocal of it. Okay, that's what you're really doing. It's a little tricky though when you're finding the reciprocal of inverses. We did it by hand on this 2x2. We're going to do it on our calculators. Okay. This time you want to pull up matrix A. Okay. And I want to find the reciprocal, which means I want to take it to the -1 power. So I'm just going to take it to the -1 power, spit it out. Unfortunately, in this case, your calculator is spitting out a bunch of gross, ugly decimals. We like pretty fractions better. Okay. So I just want to tell you that if you hit the math, and then enter, just like you were dealing with regular numbers, your calculator will now spit it out as a fraction. Okay? Now I want to show you that if I take this answer and I multiply it by my original matrix, and my original matrix was matrix A, so I multiply it by my original matrix, which was matrix A, I should get the identity matrix, which I do. Okay, I can also do it the other way around, and I should also get the identity matrix. Okay, so I can tell that these are inverses because if I take A times the inverse of A, I get the identity matrix. If I take inverse of A times A, I would also get the identity matrix. Okay, so I know that they're inverses of each other. All right, and I think that should do it.